to our first module on XBee and ZigBee technologies. We'll talk about the difference between those two in 1 second. These modules focus primarily on their application to cyber-physical systems and Internet of Things related technologies. So let's jump right in. What is ZigBee? ZigBee is an IEEE 802.15.4 base specification for higher level communications. It's focused primarily on low power, low data rate applications, and those that really only require communication over smaller, closer proximities. They're used to create personal area networks, and one of their strengths is they're intended to be simpler and less expensive and less complicated than Bluetooth or Wi-Fi networks, and definitely cheaper than cellular, which would require some sort of service plan. Now, applications include home automation, medical devices, and anything with lower bandwidth requirements. Any application that can make use of the low power, low data rate, low cost advantages of ZigBee. So the technology, ZigBee, is interesting for certain applications, and it's definitely more applicable, I think I've said this several times, for smaller scale projects. The transmission distance tops out at approximately 100 meters with line of sight. This is assuming that you don't have multiple routers or relays that are chained in order to extend that range. We're talking about just two radios with one another. But I think some of the newer technologies have increased that transmission distance a little bit. The maximum bit rate is 150 kilobits per second, and it employs a 128-bit symmetric encryption. Now, XBee. So XBee and ZigBee are not the same, and what's the difference? ZigBee, like I said just a second ago, is a communication protocol. XBee is a hardware module and form factor. It's a line of products that employ a version of the ZigBee communication protocol. They're manufactured by Digi, but there are compatible devices available. Now, we are going to work predominantly with the Digi-manufactured XBee, ZigBee-based, but XBee Series 2 module, both the standard and the Pro version. Now, Digi also makes XBee modules under that same name that employ Wi-Fi, cellular, and Bluetooth connections. So when you're buying radios, you want to make sure that you're not only looking for the XBee name, but you're also looking for the ZB. They often abbreviate the ZB, ZigBee type. Now, the newest type of radio, or the newest series, the XBee Series 3, facilitates multiple communication paths. It's actually backwards compatible with both the Series 1 and the Series 2. And so it allows you to communicate via ZigBee, and it also provides some Bluetooth capability in there. We'll talk about the Series 3 in a second and how that plays into this lesson. But the ZigBee radios, or the XBee radios employing ZigBee communication protocol, predominantly transmit, at least for US versions, using a 2.4 gigahertz carrier frequency. And we're not really going to talk about different antenna types. Now, if you go to the Digi website and you look at the different versions of the radio, you'll see there's several different ways in which they're differentiated. One is going to be the communication protocol. So ZigBee versus Wi-Fi versus cellular versus whatever else. Then there's also the Series 1, Series 2, Series 3, and then you have the Pro and non-Pro versions, which for the most part vary in terms of their power output capability. However, one other way that they vary is the antenna types. So you'll see some with built-in PCB antennas. You'll see some with external UFL connectors to which you can attach external antennas. This is not a course on antennas, and so we're going to stay away from that topic. There's plenty of other good resources and data sheets available online that can talk to you more about how the different antenna types can be advantageous to you. So XBee yesterday versus today. So XBee hardware is constantly evolving, and I think that's one of the difficult things about creating a course like this, is having to wrestle with the change of technology. And I've tried to strike a balance, because it's really not going to allow me to put out a very high quality product if I'm constantly redoing the course every time any little change to the technology comes around. So how are we going to treat the changes in XBee technology in this course. So Digi has largely retired the Series 1 and Series 2 radios, which, funny enough, are going to be the ones that we focus on in these modules. And they've retired those Series 1 and Series 2 radios in favor of the Series 3 version. Now, what does this mean for these lessons and these modules? I don't think that it really is that much of a detriment to these lessons. You can still purchase and use the Series 1 and Series 2 hardware. It may not be what you would want to design, what you would want to base a commercial product off of, but you can still find them and you can still use them and you can still learn on them. They're still great tools, like I said, for learning about cyber-physical systems and the Internet of Things. But you may need to adapt some of the lessons that we learn to work with the more modern Series 3 radio, which they specifically say on their website is backwards compatible with the Series 1 and Series 2. So the module, the videos that follow this on the topics of ZigBee and XBee are still important for several reasons. One, they teach you about the basics of ZigBee-enabled radios, which is a great starting point if you want to work with Series 1, Series 2, or Series 3 radios. It discusses the XBee ecosystem, so how to use the Connectport X2. There's other versions, but we're going to focus on the Connectport X2 ZigBee to Ethernet gateway. It also talks about the X-CTU application and how to use the Python-based APIs that Digi has supplied to developers. And that's important. Fortunately, Digi clearly says that the Series 3 radio is backwards compatible with the Series 1 and Series 2 radios. What that means is you could take these lessons and still use them in a productive manner when applied to the Series 3 radio. So availability, let's talk about this for a second. Fortunately, there's still lots of the Series 1 and Series 2 radios available online. You can check out Adafruit, they have some in stock. SparkFun, they have some in stock. DigiKey does as well, but the shot I have here, this picture, is actually from Mouser, which I just realized. There's also the Digi Store, which you can find. I don't know if this is officially associated with Digi, the manufacturer. It may just be their preferred distributor, but this website provides access to tons more parts that we're going to discuss in these modules, one of the prime ones being the X2 Connectport module, the ZigBee to Ethernet gateway. Now, I did want to talk about this book for 1 second, Building Wireless Sensor Networks by Rob Faludi. This is a great reference for those looking to build XBee prototypes. I don't know what the latest version is. I don't know if it has been updated to employ the newer S3 Series 3 hardware, but I encourage you to check it out. You can buy the textbook online, or you can also check out the website www.faludi.com. And I really encourage you to check out this book. Next, let's discuss an outline for this module. What topics are we going to discuss and in what order? Right now, we are in the introduction section. We're introducing ZigBee, introducing XBee, introducing all the topics that are going to be discussed in this module. We'll also talk about AT versus API mode, but there's no need to get too much into that right now. We'll see them in the upcoming slides. The next topic. And these are divided by video. So each one of these bullets would represent a separate video or a separate module. Next module discusses the XBee Series 1 radio. We are going to talk about how that radio can be used for point-to-point communication, how we can configure the radio using the X-CTU application. We're going to use that application in several other sections of this. Next module will be the Digi Connectport X2 as a ZigBee network coordinator. We're going to discuss how to build a small ZigBee or XBee network. We are going to discuss how to configure the XBee Series 2 radio for AT and API communication modes. We are going to answer the question, what is the Connectport X2 and why do we need a ZigBee to Ethernet gateway? And we're going to discuss how to access the Connectport X2 using Telnet. Next module, the XBee Series 2 radio in AT/transparent mode. We are going to discuss how to configure the Series 2 radio using X-CTU, the same X-CTU we used up here, as well as discussing how to use the XBee and Arduino together. Now, this is something that is useful if we're not using the XBee radio in the API mode. Still in this section here, we've already talked about this bullet. There's also, we talked about both these bullets, but within the topic of using XBee and Arduinos together, we're going to discuss how to build the basic input and output circuits, which supply signals as well as measure them. And then we'll get into the build IDE with some sample code for the Arduino. Next module is the XBee Series 2 radio in API mode. So the main difference here is we have AT mode versus API mode. We'll discuss the overview and the structure of the packets that are used. Those packets are the main differentiator between the AT and the API mode. Then we're going to go over a couple of exercises. We are going to acquire the radio parameters using a script in Python, and then we are going to locate all active Series 2 devices in our personal area network. Next module is going to talk about relevant Python methods. So the API that Digi provides is based in Python. So you need to develop the appropriate scripts in Python. And so this section here is a little bit disjoint from the others, but it's very useful because it's providing some Python tips and talking about some useful Python methods and commands that I at least found to be helpful. We are going to access an external file in Python, and that's going to include both txt and comma-separated value files. There's a couple of exercises after that, network reconfiguration and quantifying received signal strength indicators. Now, I should make one caveat here. Some of these modules are not going to be covered in the videos, but will simply be covered in the text. And there's a reason for that. As the code gets longer, it really becomes more and more difficult to explain it in a meaningful way. So, for example, this module right here, you are going to have to refer to the written document in order to acquire that information, but it's really well commented. Now, you don't have to take a look at that code. I think you can just watch the videos and still get 99% or let's say 95% of the material out of these modules, but it's some additional supplementary material. Perhaps that's the best word for it, supplementary material, for those that are maybe a little bit more advanced and moving on to more difficult, complex applications. Okay, next module is going to be the performing remote data acquisition via a Series 2 radio in API mode. We are going to discuss how to use the DDO, getParam, and setParam methods from the API. We are going to discuss how to parse raw data and extract useful measurements. And then we are going to do a little exercise and actually show the code for this. Now, this I think is a really important section right here, especially for cyber-physical systems and Internet of Things, because what we're doing is we have a sensor and we are trying to acquire information from that via the XBee, communicate that back to the coordinator, and then send that out to the internet. So this is for those of you that are looking to build physical real-world projects, this is going to be very helpful. And then the last module is talking about other Digi-manufactured devices. Examples include the light temperature humidity sensor, the wall router, the smart plug, and the analog adapter. We are going to go over two exercises. We are going to discuss how to open and close the smart plug relay, and we're going to talk about how to acquire and parse various measurements from these devices. These, just to make it a little bit clear, are commercially available products that are manufactured by Digi, but rely on the Series 2, or in this case, Series 3 radios for their communication. Next, I want to talk about building hardware. This course, these modules do not provide a step-by-step recorded demo of building the hardware, actuating it, testing it, and measuring the output. For example, I'm not going to take the XBee radio and put it into a socket and then put that socket into a proto board and show a video of me doing each step. Now, why is that? It's really just not that type of course. That would significantly lengthen the modules. I also think it would make it more difficult for me to go into more advanced topics. So these modules are really aimed at somebody with some basic or intermediate knowledge of building circuits on a breadboard, and obviously, software development as well. We're not going to start from the beginning when it comes to using Python. So I hope that provides a good explanation of why the course is structured the way that it is. Now, fortunately, the upside there is that this course does provide a higher level explanation of developing XBee and ZigBee based systems, and I think that's really what you are not going to find as many good examples of on a free resource like YouTube. And that's really what I'm aiming, the hole that I'm aiming to fill, or the need that I'm aiming to satisfy. Next, let's move on to some relevant background. We're going to talk about the Haze command set, also known as the AT command set. So this command set was originally developed in the early 1980s, and it was used to control modems. It was developed by a person named Dennis Haze. And the command set consists of short text strings. So the XBee AT commands are based on this Haze solution. I don't know exactly what the progression is from the 1980s until today, but it doesn't use the exact same command set or structure. The device, which in this case is the XBee radio, but previously I guess you could say that was the modem. So when we're talking about the Haze or the AT command set, the device exists in two potential modes. One is the data mode. And so in the data mode, the device accepts input data and communicates that information to a pre-configured destination. There's no data interpretation, and it simply serves as a pass-through. Information comes in and it's relayed wirelessly to whatever the destination is. The other mode is the command mode. And in command mode, the device, which is the XBee radio in this case, will accept inputs and interpret that data as a command for execution. Each one of the commands will start with AT, which stands for attention. Commands may be executed within the terminal emulator software. So in Windows, that would be the command prompt. And the command +++ is what actually causes the radio to enter the command mode. The XBee versions of the AT commands employ a structure like that shown below. They begin with the AT prefix calling attention to the command, the ID of the parameter to be accessed, whether that's to be retrieved or set, the optional value. So if we're setting a value, then we would obviously have to include the value to which it would be set, and then the carriage return, which marks the end of the command. So let's say, for example, we want to set the node join time of the radio, which has the ID NJ, to a value of 0xFF. That's its maximum value. We would define the command as AT, then the ID, which is NJ, then the value, which is FF, and then the carriage return. And that would set the node join time to its maximum value. Now, in the notes, you'll see there are several links to important reference tables like this documentation provided by Digi. And there are tables that essentially list out all of the important IDs that you should be concerned with, as well as the parameter range that you can work with. Next, let's switch gears for 1 second. Let's talk about the transparent or AT network mode versus the API network mode. And so I do want to make the differentiation right here that this is a network mode. Now, why do we need two modes of operation? AT mode is discussed on the left, API mode is discussed on the right. In the AP mode, information is simply passed along in a transparent manner by the radio to whatever the destination is. In API mode, this type of behavior, meaning the destinations and how data is treated, is going to be defined by a Python script one develops using the Digi API. When we're in transparent or AT mode, the radio operates in what's called command mode. So remember, there's the network mode and there's the radio mode.
not to get confused here. So when the network is in AT mode, the radio operates in command mode. If you remember, we talked about the subject of command mode when we discussed the Haze command set. Now in command mode, characters from the UART port are interpreted as commands. And we will specifically be using this mode when we talk about interfacing the XBee with the Arduino. When in API mode, as a network, the radio is simply operating in what's called API mode as well. Now, transparent / AT mode, I'm just going to call it AT mode from this point forward. In AT mode, we have the ability to achieve limited point-to-point communication, meaning that there's no coordinator for our network. In API mode, we will have a network coordinator, and this coordinator will facilitate communication within a star network of radios. So we will have multi-path communication, multiple end nodes and routers all communicating with one another and relaying that information back to a coordinator. We're going to talk about the subject of coordinators more in 1 second. The destination in AT mode is defined statically by the high and low address, DH and DL. Those are two parameters defined in the documentation. In the API mode, the destinations are dynamic and can be redefined on the fly using the Python commands. In AT mode, the destination may be controlled statically within the firmware or dynamically using the Arduino to control the XBee while in command mode. So if we want to redefine our DH and DL parameters on the fly and the radio is operating in command mode, we will need another, let's say, MCU device to act as the brain and redefine that. When we're in API mode, the destination may be controlled dynamically without entering command mode by Python scripts that are uploaded to the coordinator. My goal here is really just to provide an introduction to the differences between transparent and API modes. So if you don't fully understand it right now, that's okay. At least you understand that there is a difference. And when we get to the individual modules in this group of modules on XBee, that will make more sense. Both the AT mode and the API mode use AT commands. However, in AT mode, those commands are sent serially, and in API mode, the AT commands are still used, but sent as data packets that will also include a destination address. Now, let's talk about the ZigBee network structure for 1 second, star versus mesh, and also this idea of a coordinator. Now, the default ZigBee network structure for multi-point communication, not talking about Series 1 radios, is a star, in which the coordinator serves as the central controlling node. Routers communicate with both the coordinator and the end nodes. An end node generally acts as a sensor or an actuator, For network communication routing, each end node requires a parent as well as each router requires a parent. Generally, the end nodes communicate with routers, but they can communicate with the coordinator itself directly. So the star type network, the way that it works is that each node has only one parent. So for example, the parent of this end node is the router, the parent of this end node is the router, the parent of this end node is the router. The parent of this router is the coordinator, and this defines the paths along which information is going to be passed. This differs from the Series 1 AT mode, where we simply have radio A, and that is communicating information to radio B as defined by the DL and DH parameters. So my goal here is simply just to lay out the general structure of the star network, which we'll be using for a large number of the examples. We have 3 different types of radios, just to reiterate: coordinator, router, and end node. And this coordinator right here is generally going to communicate with the external world or with the internet. And that's why this will generally, this job will be filled by the X2 or something similar to the X2 connect port, which is the ZigBee to Ethernet gateway. All right, now talking about the difference between the Series 1 and Series 2 radios for 1 second. I think you can sort of understand the differences based on the outline. You know that the Series 1 radio is only going to be used for point-to-point communication. Anyway, so let's jump in right here. The Series 1 XBee radio is used for basic communication. It relies on the IEEE 802.15.4 communication protocol. It transmits at 1 milliwatt with a maximum rate of 250 kilobits per second. The Series 1 radios are popular because they are easy to configure and use, and they provide a basic yet reliable communication channel between two digital devices. If this is what your project calls for, you definitely want to go with the easiest solution. Although it's not going to fit the bill for most of the more modern, more robust types of cyber-physical systems and IoT projects. The Series X2 XBee radio is used for higher level communication. It relies on ZigBee, we talked about that in the beginning, a suite of higher level communication protocols for creation of personal area networks based on the IEEE standard. It transmits at 63 milliwatts for the Pro version. There's also a non-Pro 2 milliwatt version with a maximum rate of 250 kilobits per second. The Series 2 radios are popular because, unlike the S1, they facilitate creation of more complex and potentially meshed networks. You can see here, this is some documentation from Digi, and it displays the different types of XBee radios that are available. You have your Series 1, you have your Series 2, there's various versions of your Series 2, as well as your Series 3, and we're really not going to talk about the versions that have higher version numbers. Okay, a basic XBee connection example. I know I said that we weren't going to talk about hardware connections, and we're not going to in too much depth, but I thought it was at least important to provide a basic starting point. So this is a really simple XBee connection example. And what you can see is there's two really important connections. You have your pin 1, which is your supply. It needs to be connected to a 3.3 volt supply. And you have your pin 10, which is your ground. Now for this example right here, they're using the other pins as digital ins and outs. I'm not going to talk about how those are being used, but those are the two most important connections right there. And here you can see is how it would be connected using a proto board. I did want to highlight that I got this picture from a tutorial on the SmartFun website. I do always want to make sure to provide references where necessary. This is a schematic, actually I created in Eagle, the PCB software, which again shows the same connections. You can see pin 1 is where we have our VCC connected. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, pin 10 is going to be our ground, and then you can see the other labels, which we will talk about more in the later modules. So I won't go over them right now, but you have some analog and digital I/O. You have some pulse width modulated outputs. You have a reference voltage, and like I said, we'll talk about that more when we get to the appropriate point in the modules. Now, if you look at this link up here, you can actually download a design, a schematic for the Eagle PCB software of a sensor that I developed that uses the XBee radio. So if you're looking for a good design example, please don't hesitate to grab that and take a look at it. As far as my experience, I actually have published a couple papers that involve work that use the XBee radio. One of them is available in the IET library. And so essentially, I developed this sensor right here, which has a infrared sensor. It has a sound acoustic sensor. It also has a photoelectric sensitive element right there, and then there's a power supply on the back, and you can see the XBee radio. There's also a relay which allows this to operate as sort of like a smart plug. So I'm not going to say too much on this. If you want to, you can check the paper out, but I did just want to elaborate or discuss that I do have a decent amount of experience working with these radios, and this is one of the sensors that I developed.
So that marks the end of our introduction. Next, we're going to move into the more substantive modules. First, we're going to talk about the Series 1 radio and how that can be used for point-to-point communication. Then we're going to dive into the topic of the Digi Connectport X2, the ZigBee to Ethernet gateway, which will serve as the coordinator for more complex ZigBee/XBee based networks. Then we dive into the XBee Series 2 radio. First, how we can use that in AT mode, then how we can use that in API mode. The next module after that is going to deal with some Python programming, just a few basics, a few methods and techniques that I found useful when I was working with the Digi Python-based API. The second to last module is going to be one of the most interesting ones, and that is how to use the Series 2 radio to perform remote data acquisition for a sensor, either one that you may have on hand, or I'm going to use one that I built. And then the last module discusses some other hardware that Digi manufactures that's compatible with the Series 2 radio. So let's go ahead and jump into these other topics. I hope this introduction was helpful.